Alright, let's continue. Okay, let me open. Okay. I want to replace strcpy, but yeah, I'm not really sure whether we should use memccpy or memcpy here. Okay. Such a problem is part of what makes memcpy such an effective replacement. Alright, let's buffer overflow arrays when the destination is smaller than source. Safe use of strcpy requires a priori knowledge of line. Okay, let me copy this in the chat. The source string line usually this knowledge is the exact source string line. Hello, welcome. Perdon. Source string length usually this knowledge is the exact source string length. If so, memcpy is not only a trivial substitute, it's faster since it will not simultaneously search for a null terminator. Okay. It will not simultaneously search for a null terminator. It is faster. Okay. memcpy. More panic case is a static source string trusted input. I mean, if you use static or string literal, do you really need to use strcpy? The size is a compile time constant, so exploit it as such. Even more, a static assertion can catch mistake at compile time rather than runtime. Okay, using static assert. Okay. So the size of more than size of this one. Okay. Using macro. Then using size of. Okay. This covers the vast majority of cases of already correct strcpy. Less common cases, strcpy can still be correct without knowing the exact source string length. Can still be correct without knowing the exact source string length. It's enough to know its upper bound does not exceed the destination length. In this example, assuming the input is guaranteed to be null terminated, this strcpy is correct without ever knowing the source string length. Okay. This is a rare case where strncpy is direct semantic. It zeroes out unused destination byte, destroying any previous content. In this case, same as. Okay. It's not a general strcpy replacement because strncpy might not write a null terminator if we are using alt size. Okay. If the source string does not null terminate within the destination length, then neither will the destination string. As before, we can do better with memcpy. Okay. This unconditionally copies 32 bytes, but doesn't it waste time copying byte in one need? No. Okay. On mature network, it's far better to copy a large fixed number of bytes than a small variable number of bytes. Really? Far better? Oh. Copy a large fixed number of bytes than small. Oh, fixed number. Okay. Per number of bytes. Our printing is expensive. I'll copy this in the chat. Because anyone wants to take a look. Searching for and handling that null terminator has a cost. This fixed size copy is literally two instructions on. Okay. And there's no strcpy to attract complaint. So where is strcpy useful? Only where all of the following apply. You only know the upper bound of the source string. It's undesirable to read beyond that line. Maybe storage is limited to the exact length of the string or the upper bound is very large. So a non-conditional copy is too expensive. Unconditional copy. The source string is so long and the function so hot. What? That it's worth avoiding to passes. That it's worth avoiding two passes. STR length followed by memcpy. Oh. The circumstances are very unusual, which make and it's pretty dumb. Okay. Using Carlog, interesting. Right, we're using assert instead of static assert like this. It is different. Static assert, what is it called? As far as I understand, evaluate during compile time, and assert is evaluate during runtime. That's why we can use strlen. I mean, if you try using static assert with strlen, you might get a compile error, I guess, because strlen is not constant, something like that. If you are dealing with such large null-terminated string, okay, let me put this manual page. Where is it? This macro similar to assert, but it works at compile time, generating a compilation error, an optional message when the input is false. Message must be a string literal. Okay. Value return can be used in some place. Must be. Oh, I didn't know this macro exists. Interesting. However, it always returns 0, which allows using it everywhere an expression can be used. Okay. Oh, no manual. Okay. But yeah, I might be wrong for static assert. But that's what I know, at least. If you are dealing with such large null-terminated string that what is it to entry apply, then you are already doing something fundamentally wrong and contradictory, I guess. The pointer and length should be kept and passed together. It's especially essential for a hot function. And length should be kept and passed together. Say string optional is a size T with a restricted range, probably says my. Oh, okay. intended to catch integer underflow. If you accidentally compute a negative length, it will be a very large number in unsigned form, right? An indicator that size t should have originally been defined as signed. Okay, interesting. This will be outside the restricted range. Oh, using const and restrict. Okay, so the operation is an attempt to read the unlikely underflow. These functions were modeled after functions of the same name in MSVC. However, as noted, there are no practical implementation of Annex K. The functions in MSVC have different semantic and behavior, and they do not attempt to implement the standard. Worse, they even do what's promised in their documentation. They don't even do what's promised in their documentation. The following program should cause a runtime constraint violation since negative 1 is an invalid RST. Let me check. Is it in limits? Size? No. Okay. Did not make my program any safer than I just use strcpy. If anything, it is less safe due to a false sense of security. Okay. Now I'm curious. I know that there is this memccpy, right? We also have, what is it? The check for specific character. I did try that out in this one. Okay. This one we check for null terminator. If it is found, then this pointer become the next is not null, and that's the point. The next memory address of character, but yeah, it is not null. Wait a minute. Found one. Okay, looks like I forgot to recompile to the new, right, this one. If the null terminator is not found, or the pointer or the return value will become null. Now I think I found this one. Comparison of the use memccpy and memcpy. I haven't read this. Let me copy this in the chat. Void pointer as a return value. memccpy, the extra C, okay, is used to copy source refers to the content of the memory of the first n bytes. This is the n. The address refers to destination. Unlike memcpy, memccpy checks for the presence of parameter C in this one. This one is kind of confusing, right? What is it called? The parameter name lowercase, but in here uppercase, and this one is vice versa. So anyway, at the time of replication, if it returns the next byte address in the test with a value of C, if it returns the next, checks for presence of parameter C at the time returns the next byte address in destination with a value of C, this one. Returns the next byte pointer to destination with a value of C. I mean, I'm not sure if what is it called? The next byte is a valid memory address or not. But well, as long as we don't use this pointer, it should be fine, I guess. Maybe. I'm still not sure. A return value of 0 indicates that there are no bytes. Right, the null. There are no bytes of C in the first n byte of the memory refer to in the SRC. This one. This is the example, right? We check for P, okay, uppercase P. Alright. But yeah, we didn't save the return value. Okay. String A, string B, this one. The uppercase and lowercase of this is kind of confusing. But well, let's assume everything is lowercase. This is B. Size of B. Okay. Now we are using string literal in here. I think this is What interesting, even though we did not find the character B, oh, if this is a lowercase b, it should stop at this, right? And now why is it print out all? Interesting. Is this because buffer overflow, the non-terminating stuff, again this string, what is it called, format specifier, string format specifier will need to find the, what is it, the null terminator. Maybe an example like this. See, it will keep printing out until we found the null terminator. It is in str, this one. This is the mild example of buffer overflow. Something like that, I guess. So, yeah, maybe this is the result of buffer overflow where we print until we found the null terminator. I mean, we are using string literal, right? There's a null terminator at the end of string literal. Copy memory content. What is ignore in here means? I have no idea. Copies the first byte of the memory content src to the memory address. Destination refers to, does not care about the data type being replicated, but replicates in byte, which give a lot of flexibility to the use of function and can be replicated for any data type. Enough space or greater than the byte. If there is no space allocated, a brick or error occurs. The memory space referred to by destination and source cannot overlap. If overlapping occurs, using memmove is more secure. Okay. Unlike strcpy, memcopy or memcpy copies the bytes completely and does not end with null terminator, I guess. I assume. Value returns a pointer to destination. Note that the return pointer is void and is typically used coercion type conversion. Let me check. Is void pointer though? It is a pointer, not really void. Pointer to destination. Okay. Looks like this is not something that I expect. C programming MemCPY difference between MemCPY and designing better STL-CPY. Wait a minute. Oh, Flipping. Destination source 0. Okay. Except that the former turns a pointer to the end of the buffer written and does not zero back the destination array. Is it really the end of buffer written? Let us check. Found, right? Okay. And then bar 5 maybe. Like this. Alright, I think we should use the offset one, not the array subscript. Something like this. Oh, okay. With the offset 5 or the offset 4. Let's check that out. Okay. And what is this? It is a null. Wait. But then let me check. It should be buff size -1 because we are starting the index from 0, right? A. Oh, interesting. Yeah, it should be like this. So now we got the null terminator, I guess. Let me check. Alright. Well, in case you are new in ANSI character set, null is 0, I guess. Okay. Combination between pointer and integer. Right. Pointer and integer. This is a pointer. Let's do this instead. No terminator. And then okay, still the same. That is interesting. So it should be plus offset -1, right? From what I understand. Something like this. And it is different. Okay, looks like it literally the next character. Not really the end of the buffer, right then. Okay. There is mosquito around. Okay, anyway. The next character. But the usage is the same. The buffer pointed by this and bytes from must not overlap. Is there yeah, this is interesting. There is a little information about memcpy. And pipe and stop if character C is found. Let me check this one. It makes it easier to read and to be becoming. Does not have to jar. Okay. Theory means to unsign jar. There's one implementation. Converted to an unsigned jar after end bytes are copied, whichever comes first. If copying takes place between okay, let me check. Okay. Center. Control it. Okay. And center. Using two wire. Okay. Well, you see this one, right? Return TP. Okay, after we incremented. Alright. Maybe that is why we throw this code. ST1. Okay. Let me commit this. Our playground at, what is it called? Last in sample. Oh, to check whether the return value is the next memory address of MCCPY. And it turns out which might or might not be valid. Question mark. I'm not sure. Hello Luigi, welcome back. Yeah, I just do a haircut. What are you doing? Okay, I'm trying out to replace strcpy. Basically the function to copy string. I'm looking for an alternative to check, and one of the candidate is memccpy, this one. But yeah, I'm not really sure if this is a good idea or not. So let's find out. Okay, let me copy this in the chat. Copy no more than n byte of source to destination, stopping when C is found. C as in here, C is found. Return the position in destination 1 byte pass where C was copied. Return the position in destination 1 byte past where C was copied, or null if C 1 byte pass. Oh, pass mean the next byte, I guess. One byte past where C was copied. So in our example, in here, where is it? In here, right? As we can see, this is 453, and this one is 452. Something like this. This is the returning address from the memccpy, but this is the last address from the, what is it called? From the buff size, from the size that we provide. C was copied or null if C was not found in the first n byte of src. Oh, where C was copied. Or okay, so where C was copied. So this one, this memory address is what is it called? Is the address from the null terminator, and this one is the next address after the null terminator that we found, which might or might not be valid if I understand correctly. Let me check. Okay, right. Oh, wait a minute. So underneath we are using memccpy. Is that a function again? Okay, interesting. memccpy function is not identical to copied n bytes from object beginning at src into the object pointed to byte destination, but instead of returning the value of destination, it returns a pointer to the byte following the last written byte. The last written byte. This function is useful in situations where a number of objects shall be copied to consecutive memory position. Let's write on byte. Okay, wait a minute. Let me check. This is a POSIX 1. So is this, oh, this is not POSIX. Okay. And what about memchar? No. Oh. Okay. This is POSIX. Interesting. Find pipe. Okay. So we check the character with memchar shall locate the first occurrence of C converted to an unsigned char. the located byte or a null pointer if byte is not found. And this is the interesting thing. We are still copying to the destination. If, what is it called? If the jar is not found, one byte password say was copied. First n byte of source. Yeah, I'm not sure. Let me check. String mem.csl. Okay, let us check. Okay, let's say okay. Oh. I mean, well, this one might be slower than just the mem copy. Probed. By the way, I'm learning C++. I was making a namespace for practicing to understand what headers are for. Could you explain me? Thanks. Headers, huh? Okay, let's check that out. I mean, I'm using headers, what is it called, to, what is it, declare some of the function prototype, I guess. Oh, not that one. Something like this, so that I can have the function prototype or declaration in another C code without actually including all the implementation. So where is it? Like this one. I can use this function, right, with just providing the header rather than providing the C or the implementation in the C code. That's as far as I understand, but let's take a look. What is header file? Okay, it usually contains features like function data types macros that can be used by any other C program. Okay. So if I understand correctly, people usually publish their library with a header file and binary file, something like this, to make to save compilation time, something like this. So to save compilation time, people usually only publish the header file and the binary file, or maybe shared object is the right word. Shared object file. So we don't really need to compile the whole implementation again. We just provide the header file, like to get the function prototype and something like that. In case if you are new, function prototype is it's like we are declaring a function, but we haven't give any value to the function or any declaration, I guess. It is like you doing something like this. I, and then we are adding a value in here. And in function definition, we can do this. This is the function definition, or maybe function prototype, right? And then we can declare that later on, or sorry, not declare, define the function later on. Let's say printf or whatever it is in here. Maybe I can give you an example. Let's do a classic add function, right? Okay. This is the one, the function prototype. And then we can declare that later on, or define that later on. A. So it's like you're planning for the function that you want to have, the return, the return value and the parameter inside of the function, and then define this function later on. Return a plus b, not a plus a. Okay, something like this. So yeah, it can be It can be used to plan something. So let's say if we change the definition, right? Something like this, for example, B, we will get a compilation error. Config string type. So kind of safety guard, you could say. No, it is fine. So I usually think function prototype as as a planning base, what I want to create, right? What the function that I want to make, and then I implement that or define the function later on. That is a little bit of explanation about function prototype as far as I understand. Let me copy this in the chat. Is this Vim? Yes, this is Vim. Okay. C language use header file to provide the standard library and their component for use in program. So for example, in the in this limits.h header file, let me check this one. Where is it? Oh, I think it is in the user include. Okay, let us check. User include limits.h. So this is the header of the limits.h, right? And as we can see, well, there's a lot in here, but mostly it is the definition or the macro, I guess, right? The macro for the limit for this machine. That's not really I think that's not really a good example. Okay, this is the header for the standard I/O, standard input output. Is there any function prototype? Yeah, it usually used for defining stuff, or maybe declaring stuff is the right word. Oh. Yeah, I cannot find. Oh, maybe this one. Okay, this is the function prototype of printf, and then we use the set object file to compile that with the implementation of the printf. So it's like all the declaration of the function and maybe some macro too. Yeah, it's like we declare something first in the header file so that we can use the declaration in another C file. So like reusing the declaration in another source code, something like that. And then, well, of course we need to provide that tooling compilation too. this one. Right, this is the implementation of the header utils. So if we did not, what is it called? If we did not provide this, maybe something like this, we will get an error. Right, undefined reference. So we have the declaration of the function, but we have not implement the function yet. So that is why we need to provide this implementation during compilation. But if we have the object, like we are doing this with the libmpc8.h, we can provide that instead. So we don't need to recompile the, what is it called? Recompile the source. Right. We don't need to recompile the source if we already have the object in it. Like this, compiling the object. Right. So if we do this again, it works fine. And if we do this, right, can we like using time? Okay, it's around what, 0.3 second. I forgot what is the times. What is it called? What does this mean? Let's put it that way. But if we use this, right, it is faster than compiling the parser. It is the MPC parser, right? So it can quite save some time, you could say. So if we do something like this, right, it is significantly slower, I guess. But I'm not sure if it is significant or not. But it is slower than just providing the object file. It is the, what is it? This one, the mpc.o. And I put that in the archive. You can think of it like the zip file, something like that. Okay. Lib pca.a, which I just realized later on that I can put multiple object file in this archive. So yeah, that's, I'm not sure if that explains it, to use its feature. I mean to call the function, right? Like this one. To use add function, we need to declare it first. Let's try this. In add 1 right? If we didn't provide this, if we provide this, we can use this in here. Let us check. Okay, no compilation error. But if we comment it out, right, we get a compilation error because the compiler did not know what it is. I mean, you could put this at the top to fix that, right? Something like this. But we can put this in the header and then use that header instead. Maybe something like this. In add, in, right? And then we include that in here, maybe include inno.h, compile that. It is because, well, let us check. Inno.h, we already kind of embed the header, so we have the declaration for this function. But then again, if we did not define the function, it should, oh, my stomach's growling again. I need to get breakfast after this. See, if we didn't provide the implementation of the function, we would get a compilation error and the find reference to add. So it's like what providing the reusable function or another declaration such as macro declaration or something like that, and we can use that in another C source code. That is as far as I understand the use of header file. But let's read this. I don't think this is the explanation. Understanding. Let's check this. Okay, they act as a bridge between the implementation of code and its usage, ensuring that different parts of a program can communicate effectively. Ensuring that different parts of a program can communicate effectively. And copy this. Oh, itu bro, also when in C++. Code is an object and not a function. Okay, so I haven't learned C++ yet, and as you can see, C++ and C is kind of different. I mean, they have some similarity, but it is mostly different, I guess. So I'm not really sure about the code. Yeah, for example, I think, what is it? C++, hello world. I think this one. Right, in the C++, you're using this, right? Static out, hello world. But in C, now let's try this out. Include IO stream. As far as I understand, see, in C there is no IO stream. It's only in C++. So there is some kind of the difference between C and C++. So if you are trying to run this with the C compiler, you will get an error. But well, if we want to try this in C, we can, where is it? Maybe I will use another file. Oh, what is it called? .c. Yes. If we want to replicate this in C, not C++, we can do something like this. Main void return 0, right, and then printf hello world. Compile this. Okay, and then running this. Alright, I need to give. I'm not sure if in C++ we need to give a new line or not, like this. But in C, yeah, we need to do that. Okay, hello world. So yeah, there is some kind of the difference between C and C++. So I'm not really sure about the code in here. What does it mean? Let me copy this in the chat. Maybe it will give some insight or something like that. It's the format string, okay. Must include IO stream. Yeah. Code is an object. Code? What is code? CO. Maybe it is called cout. How does code actually work? Okay, let me copy this in the chat as an instance of something. Static cout is able to use, okay, as it does. And main measurement is with the fine. If I do this for a custom class, return instead of some sort, could implementing it as kind of a hack with void pointer or something. Okay, maybe you can take a look at this. But yeah, I I haven't learned about C++ yet. Perfect, because for example, Python you use print, it is a function and you pass what you want to be printed as an argument. Yeah, in Python we can use print, right? I mean, if you're new to programming, you might want to build up some kind of, what is it called, understanding about the print function and the looping or iterative, like the for loop, while loop, and so on. So Python can be great to start with learning the, what is it called, learning programming for the first time. But yeah, the C++ syntax can be quite overwhelming, more so than C. But well, we can choose whatever we want, I guess. That's why I'm learning C first, and maybe I will take a look at C++ later on. But who knows? Anyway, right, okay. Maybe I can, what is it called? I can give another example, like we can define this in another C file. Let's call it, what is it? Im in PL for the implementation. Right. Okay, this one. And then we can provide that during the compilation. And now, and we see in it works fine, right? Okay, let me print F. Let me print this one. Okay, and then I know to kind of see what's going on. Kind of see the result. Okay. And now if we try to, what is it, exclude this, right, you will get an error because we have the declaration of function add in this header, right, and define reference to add, but then we don't know the implementation of add function or what this function do, right? There is no, what is it called? There is no function body. So I think this is the linker error. Yeah, I'm not really sure yet. So the compiler kind of confused, right? We have this function, but what this function do? The compiler have no idea. So we also need to provide the implementation to tell the compiler, hey, this add function do something like this, have an instruction like this. In a way, you can think of function body, the one that I highlight, as an instruction for the function, you know. It's like we are planning this. I want to have an add function, and then to find the instruction for this function in another file or at a later time, right? So this is kind of like the instruction for the function when we call the function like this. And I think if we don't call the function, it should be fine, right? If we didn't use the function, we don't need to provide the implementation. But if we use it, then yeah, we need to find or implement the function body, something like that. Do you use the auto data type? Okay, auto data type. I don't think C have auto data type. C programming auto type. Okay. Wait a minute. Oh, yeah, I didn't know this exists. Okay. I learned something new, I guess. In my course, I actually forgot what it is. Okay. It is defined as a local lifetime. Infrequently asked question to find or declare of vehicle. What? Market outdoor. Will lack any sense of humor. Okay, let me copy this in the chat. So for your question, Luigi, I don't use auto type for now because I don't know it exists. And I still have no idea what it did. Is that there is never any reason to use auto at all. Okay. Is with variables that it has auto storage class. That would happen anyway. Wait, but is it different from the C++? I'm not really sure. If it is different, then yeah, I'm not sure. Word storage class specifier that didn't serve any purpose. However, I've tried what auto does, and it assumes the type of whatever I happen to assign to it. Auto makes code involving iterator. Since when? Okay. Only forever. That it wasn't load or. Oh, looks like it is different. The auto keyword in C++ and C. A data type was new with C++. Okay, I think it in what is it called? In JavaScript, it's like any type. or maybe TypeScript, sorry. TypeScript is like any type. So we don't know what type it's gonna be, and then we get the type from the value assigned to the, we get the type from the assigned value to give the variable the value. Something like that, I guess. Okay. Yeah, if that is what you mean, then no, I don't really use that. Because it looks like the implementation of auto in C++ and C quite different, Maybe. Yeah. Again. Modifier like static. Okay. Variable, however, since the default file is auto, you don't normally need to manually specify this. Yeah. So, for your question, Luigi, do I use auto in C? No. But, well, in C++, here it is. However, in C++, has been hijacked to support the type inference, right? The variable can be taken from the type of its initialization. Okay, let me copy this. So yeah, there is some kind of difference. It can be helpful. What is it called? It can be helpful to use the auto keyword for the type inference, right? When we are not sure what kind of type it will be. But the thing is that debugging that can be tricky, because you get the type when you run the program, right? So you need to know what is the condition or state when you run the program, or you assign the value to those auto variable or something like that. So there is a pro and cons using that. Just be careful of that, I guess. Okay. This is the header file. I hope I have to finish the explanation of header file can make you understand a little bit at least. I mean, again, my explanation might be incorrect, so I'm also learning this myself. Code reusability, right? Organization, easy debugging and maintenance. Oh, easy debugging and maintenance. Okay. Without modifying the main program. Okay. Okay, comparison of code. Maybe, but I think this is subjective. Okay. Collaboration benefit in larger project. team member can work on different modules with shared header file. Right? Yeah. Think of the header file to share some kind of declaration, reusability, something like that. And maybe organization too. Who knows? Reducing redundancy. Okay. From implementation. Okay. Let's go back to here. Where is it? Is it in here? No. Okay. Do I want to use mem ccpy or strcpy? Yeah, this doesn't have the POSIX 1. It's not POSIX compliant, okay. Or POSIX definition, maybe that's the word. Following the last written byte. P negative source and then +1. Okay. Let me try string. Okay. Let's use void string cpy. Okay. But yeah, if the destination, what is it called? If the destination is smaller than the source length, it can be bad, right? Let me check the goal implementation. Okay, for anyone new, let me copy this in the chat too. Basically, core have its own strcpy implementation, right? A string length less than destination size. We copy that just using mcpy and then give the, what is it called? The last length to 0 or null terminator, I guess. Okay. But what happened? What happened when the destination size more than the source line? Oh, sorry, less than the source line. Is it gonna do nothing? Okay. Of course, that is should affect. What is mundo? Thing can be less than 0. Less than 0. Enter and the code ID. Check for if it's 0 where it matters. And it also shouldn't be done before checking. When is it's neutral? Okay, let's take a look at this. Let me copy this in the chat. I searched lots of code and found passing any size no matter what is the length. But would also accept mistakes. Right. Okay. And we still use C89 and call. Oh, okay. Server API terima. Don't have the same signature. What bit the setup? Simply no terminating. It's not possible to determine if the size tag fail if the source is legitimately an empty string. It would be particularly confusing in some cases. Besides, it may not be apparent to the caller when they are getting an empty string back. There's no way at all to detect is when source length is not less than this size. Does not treat source as a string. Set the functions in. Okay, but it must be done by the function. Another thing is that if the buffer size fail, just continue. This is what is it called? Kind of my question, I guess. What happen if the buffer destination is smaller than the source? I mean, if we take a look at the code at glance, we only check this one, right? And else if the destination sets the destination size 0, we just null terminate, just give the null terminator there. But what happens when something like this? More than or equal this size? I'm kind of curious. Is it gonna be an error in this one, debug assert? Okay, let's take a look at the comment again. It is assumed the copy succeed. Set the daily cutoff of success, and this would be a bad pattern. Not worse than strcpy and not. See. You can skip. Why not returning something else than void? src link to always work like strcpy. The assumption is there because it is assumed that we mess up somewhere we get that in testing or parsing, not in production. The idea is that this function is always used where it succeeds. Thus, checking for success is superfluous. Okay. Must invokes the yes, not also we don't use the function. And doing conditional not to be fragile in the past. I later work on reducing the CLN calls in the parent function. Okay, let's take a look at this one. this is what we are copying. Right now, the asset is there. I mean, is debug assert evaluate during compile time or runtime? I mean, maybe it is. Let me check again. Maybe it is evaluate during compile time. That is the expected. Maybe the expected result. If what Daniel said here, if I understand what Daniel said here, why the asset is there? Because it is assumed that if we mess up somewhere, we catch that in testing or fuzzing, not in production. In the parent function. Attribute warning, okay. To use it, that is here. Correctly and suddenly evolve into something. Reinventing their own string. But the reason is that there is nothing that is at the same time convenient, right? Safe and portable. So everyone requires their own set of function. That's already be the first thing to think about when replacing. Looks okay. Doesn't. That is a tacit that is not expected to do so. In such poor language as C. The C language string interface is that for language. No use of this function anywhere in code. In the code are there is used wrongly after a future edit. Oh, that's not really the function filing. That is the function being used the wrong way by the calling function, and the condition are there to limit the harm the function does. Oh. looks the word use if really safe to truncate. Let me check. Si programming okay. It has a POSIX. It is in POSIX standard, I guess. Performance like that. Under the hood. Function can be evaluated at compile time if certain restrictions are met. Can use pointers. Call-C function. Oh, in this one. Copywriting. Environment tile. Negative one. It will return the pointer plus it replace. Read the first word, but notes it so that bytes before the array will not match goal. So do we let me think. But the interesting part is that when the character is not found, we still copying the memory. I mean, let me think. I think for our use case, we always have the same, what is it called? The same memory size between the source and destination. So maybe we don't really need MCCPY. Let me think. I mean, if we need to look for, what is it called? To look for the null terminator over and over again. It might be redundant. Yeah. What is it called? My concern is when the destination length is less than the source length. Okay. Less than the source length. Well, let's try using MCPY instead. The unlock size, the destination size, okay. Message. And then unlock size. Okay. And then again unlock size. Something like this. Hit compile. Okay. Uh, 69x and then y arc 6942 arcs x y. Okay. explain this. Because we already know the destination and source. The destination and the source. If different memory allocation, and we know that the size, the destination size, let me check. Did strcpy what is it called? Add a null terminator. Let me check. Let me like that. Okay. This one. Ellipse. Source code. RCPY. STPCPY. STP. If the buffer size of destination string is more than source string, then copy the string with terminate no character. Buffer size is more than source, but if destination buffer is less than source, then it will copy the content without terminating no character. So strcpy did not terminate to. Okay. I think I can check that out. Okay. What happened if we do this? One, right? Offset by one. CPY. Okay. Take pass into region of size 2. Overflow destination. Okay. It is overflow. We get a warning from the compiler. Segfault. Why is it segfault? Did we not copy this? Oh, right. CPY, okay. B. If we do this, okay. We did not have no terminator there. Okay. Alright. Go to out. Oh, what is a zero here? Okay. New allocation. Okay. We know that destination I mean okay, so save different memory. We know that the source has no dominator already. How do I explain this? And we know that the destination has the same length, guess. Using mem. Because we know that the destination and source size is the same on different occasion. Also, We'll make sure that IT has null previously on alpha L. In this one, where is it? This one. Where is it? File name? No. Let me see. I think this one. Get telling me seats. But the important thing is that this one SN printf null terminate the string, if I remember correctly. Quoting that terminating loop. Output was truncate to return this limit, then the return value is quoting the terminating null pipe. So if we hit the limit, then at the end we will have null terminator or the null pipe. Excluding, then the return value is the number of characters being written to the final string if enough space. Excluding the terminating null pipe. Which would have been better. Size or more was truncate. Coffee. wait a minute. Where is it? If enough space has been available, it's more. Was truncate? What happened if the output was truncate? Like the way. Okay, why is it change? What is it? Yeah, why? Okay, check out. Okay. STR. Let's do it in here. Or as custom. Okay. Let's set the message custom. Okay. Let's set the message right. We actually don't really need this. We need this for the new line character. Okay. That make me thinking. Custom, okay. Okay, right. I kind of forgot this one. And then so we got message. This one, okay. Egg, right? So what is the result of index 7? Zero. Okay, it is no terminator. What if, let me take this one. Oh wait, I think status test to 6, right? Okay. SN printf still 8. Let me check. Interesting. Okay, is LF. Satu karakter string buffer. Karakter string buffer. Most I spy. Most encoding low to STR. Okay. If size more than or equal 1, oh, string plus its or under size. And no byte is what I need to byte. Need to know how big. Okay. I mean, we are using mem copy for error message and symbol, right? And well, the symbol. I'm not really sure if we have okay, but anyway, let's unless the parser did not give a null terminating symbol like this. Okay. Let me commit that. Refactor use you know what? I kind of want to create. I think I want to use this instead of mem copy, to make sure that we have null terminator. Okay, not that one. Exit. No terminator not found. Okay. The mem CPY. Destination. Okay, I guess that's it for now. Thank you for watching and see you next time. Bye bye.